So where we ended the last video was right here on the second Pythagorean identity. To get to the third Pythagorean identity, take the first Pythagorean identity and divide it by sine squared of theta. So I'm going to take that first one again, which is sine squared of theta plus cosine squared of theta is equal to 1. And this time, I am going to divide every single term by sine squared of theta. And just like we talked about last time, even though these are squared terms, we can use reciprocal identities and we can use quotient identities to turn them into something more simplified. What is sine squared of theta divided by sine squared of theta? If you know, say it out loud. What is cosine squared of theta divided by sine squared of theta? If you know what that simplifies to, say it out loud. Cotangent squared. Don't forget. The squared makes this one squared. If it was just a cosine over sine, it would be cotangent. But because there is a squared over a squared, this has to be cotangent squared. Equals, let's use a reciprocal identity, which 1 divided by sine squared of theta would be cosecant squared of theta, which is your third Pythagorean identity. Something that helps me when I'm memorizing what goes with what. I know that cotangent and cosecant are in the same formula because they are co-captains. Since they both have the co, I think, oh, those go together. The cos go together, whereas tangent and secant go together, whereas sine and cosine go together. Once again, it's going to be really helpful for you if you memorize the 3 formulas. The sine squared of theta plus the cosine squared of theta is equal to 1. The tangent squared plus 1 is equal to secant squared of theta. And then, of course, 1 plus cotangent squared of theta is equal to cosecant squared of theta. That will help you when you get to your test. There's nothing else allowed, so keep that in mind. All right. Now that we are done talking about where those come from, now we're going to get into the meat and the potatoes of section 6, and this will even lead you into section 7. Meaning, you will have some problems that you have to simplify, and I cannot give you directions on how to handle every single one. They are so different from each other that I could only generalize it in these 4 things to try. They're basically hints. It is impossible for me to show you how to simplify every single situation that you are going to come into contact with. Well, Mr. Promo, you never showed me how to. Well, guess what? I'm sorry, I can't. There's too many to show you. Too many different kinds. But the one thing that I can say, if I were to try to generalize it, is that you're going to be using these 4 things all the time. In almost every single problem, you will use reciprocal identities. If you don't know what that means, look at the top of your notes. There are 6 of them. The sine of theta is equal to 1 divided by the cosecant of theta. You can move something from the bottom to the top using a reciprocal identity. Quotient identities, the tangent of theta and the cotangent of theta. That's at the top of your notes. And then, that's what we started with. You might have to use some GCFs except with trig functions. You might have to pull out a sine of theta or a cosine of theta from both terms and use parentheses. If you do not remember how to do GCF factoring, take a look at your 1.2 notes. You might also have to do difference of squares factoring. If you forgot what difference of squares factoring is, it's in 1.2. But the only difference is, difference of squares, you might have a sine of theta or sine squared of theta minus 1. You might have to split that up somehow. You also might have to FOIL. Binomials squared. Sometimes that will get you something squared, and that will help you use a Pythagorean identity. Don't forget to distribute things. That might help. And lastly, anytime you see a trig function squared, like a sine squared of theta minus 1, or a cotangent squared plus 1, look for a Pythagorean identity that you can use to make it more simplified. These 4 things are just general things that you need to try. The problems are going to be extremely varied. What do I do, Mr. Promo? You're going to use one of those techniques. They're extremely varied, and to the point where you're going to go, what do I do? And I'm going to say it's going to be one of those 4 things. We'll talk about these examples. I have 1, 2, 3, 4, 5, 6 examples just to show you different types that you're going to do and different techniques. Some other things that I want you to know. If you get stuck, turn the problems into sine and cosine. Never leave a trig function in the denominator. For example, if you get to a point where you have 1 divided by cosecant of theta, well, that can be simplified. You could use a reciprocal identity to make it more simplified. This will be not a full credit answer. The full credit answer would be when you move it up using its reciprocal identity. Never leave a trig function in the denominator. Use reciprocal identities to bring up to the numerator. This is a full credit answer. This is a -1 answer. And I want you to avoid all the -1s that you can. Got it? So, let's do some examples. Simplify the expression using trig identities. Sine of theta divided by cosecant of theta can be simplified. You have 2 separate trig functions. I want you to change the cosecant of theta into what you know it's equal to, and then instead of dividing by that fraction, multiply by the reciprocal, and then simplify it. I want you to work out your answer and then show your answer to the person you're sitting next to and have a quick discussion whether you think your neighbor is right or you are right, or I think it's this because. Try number 11 with your partner. Go. And you may discuss, of course. How many of you are still working on number 11? Raise your hand. 2. Okay, for the people who are done. For the people who are done. Say what you got for your answer out loud, please.
Sine squared of theta.
Perfect. Most of you said sine squared of theta. That is correct. How many people did not get sine squared of theta besides the 2 people who didn't finish? 1, 2, 3, about 5. So here we go. I know that sine of theta is the same thing as sine of theta, I also know that the cosecant of theta is the same thing as 1 over 1 divided by the sine of theta. That's its reciprocal identity. That means this is the same thing as that. So if I'm dividing this divided by 1 over sine of theta, what we're actually doing is we're taking sine of theta and we're multiplying by its reciprocal. Instead of dividing by a fraction, we multiply by its reciprocal, and that means we have 2 of these sine of thetas multiplying each other divided by 1. I don't need to write divided by 1. This simplifies to sine squared of theta. Almost all of your answers, bless you, almost all of your answers will simplify to one small whatever. That's what's satisfying about this section and these last 2 sections, as a matter of fact. I think these are kind of fun because I figured it out. It becomes this because. Number 17 is a little bit harder, but not that much harder. Simplify number 17, and then if you figure out what you think it is, tell the person you're sitting next to, and we'll go over it in 60 seconds. Go. That was 65 seconds. How many people? Ms. Promo, I got stuck. Raise your hand. I got stuck. Oh, over half the class got stuck. Like I said, I cannot show you all of the problems. You will end up using one of these 4 things in any of the problems that you get stuck. It's not a reciprocal identity. It's not a quotient identity. What if we factored using a Gcf first? Now let's try this one. Is there a Gcf? First of all, let me just say this. You cannot add 4 cosine squared of theta plus 4 sine squared of theta because those are not like terms. You can only add x squareds with other x squareds. You can only add sine squareds with other sine squareds. Those are not the same thing. You cannot put them together the way this is. So let's use a Gcf. Is there a greatest common factor here? What is the Gcf? If you factored out a Gcf of a 4, what would be left in the parentheses? I bet you know what goes here. Tell me. Say it out loud. Good. Plus. What goes here? Good. And so what we have is 4 times, in parentheses, cosine squared of theta plus sine squared of theta. Now look at that. It's 2 things, and this is one of your Pythagorean identities. Now when I look at 4, if you see a trig function squared, look for a Pythagorean identity. What does that mean? That means, do you know what the first Pythagorean identity says? What is the sine squared of theta plus the cosine squared of theta? That's equal to something. You are right. This, let me show you what I do. I put a little thing underneath here. That's going to let you know that I'm using a Pythagorean identity. If you use a Pythagorean identity, if you just put a little thing like that, you're just saying, hey, Mr. Promo, I know this is an identity. This simplifies to 1. But there's still this out there in front. And what's the 4 doing to that number 1? It's multiplying it. And so what's your final answer?
4.
So satisfying. Nice, simple. We used GCF factoring, and we used one Pythagorean identity. Does it make sense? You have to add that to your tool belt. You have to look for things. Oh, that's what we're going to have to do. Yes, because we cannot go over every example, right? It only gets harder because I may not just use Pythagorean identity number 1. I might use Pythagorean identity number 2 and 3. I'll give you a hint on 21. You should be using your first and second Pythagorean identities to simplify this first before you even keep going. Okay? So this one I'm going to give you a little bit more time. Let me give you about 3 minutes. You try it. Talk to your partner. If you need help, ask them. Anybody who's watching the video can always fast forward. It's not a big deal. But go 3 minutes and we'll talk about it in 3. Go. It has been 3 minutes. So let's hear, first and foremost, before I hear answers, how many of you, I got stuck, Mr. Promo, once again? Half. Thank you. For those of you who did not get stuck, what did you get for your answers? Say it out loud. Oh, interesting. I heard 2 different answers. One of those answers was correct. I think when I did it in my head, which I could be wrong, I got negative secant squared of theta. How many got negative secant squared of theta? 1? Well done. That's what I got. But I could be wrong. I just did it in my head. Let's find out. First thing I do. Secant squared of theta minus 1 reminds me of a Pythagorean identity. I see, let me just zoom in a little bit on this. I see a trig identity squared. This is number 4 in my hints. Number 4 says if you see a trig function squared, think of a Pythagorean identity. Well, which one would I use? I would use the second one. Secant squared minus 1. Think about if you subtract 1 from both sides, you would have that secant squared minus 1 is the same thing as, let's just change this out, to what? Tangent squared of that angle. Okay? Well, if I took this one from 2 terms into 1 term, then I should hopefully be able to do that same thing with the bottom. I'm going to try the same thing here. Take it from 2 terms down into 1 term, and that should make things easier. So, what is cosine squared minus 1? If you subtract 1 and you have the cosine squared minus 1 on this side, zeros on this side, you have to move the sine squared to the other side, and what that does is it turns cosine squared minus 1 into negative sine squared of theta. Now, the advantage of doing what I just did. No longer are you taking 2 things and dividing it by 2 things. If you think that you can simplify the 1 and the 1, you cannot. You would be breaking order of operations. Anybody who tries to reduce top and bottom, when there's a line that goes across and there's plus signs and minus signs, you are breaking order of operations because, specifically, when you have a long line that goes like this, it means this is in parentheses. You have to do that first before you do the division. You have to do this first before you do the division. If you start reducing and you divide before you've done the parentheses, that breaks order of operations. Do not try to reduce top and bottom when there's adding and subtracting signs with them. I'm saying that for the record because I see that all the time. Now we're here. I think this simplifies as well. I'm going to turn the top into something. The top is the same thing as sine squared of theta over cosine squared of theta. Isn't that the same thing as tangent of squared of theta? Divided by, this stays the same. Well, this is a complex fraction. Instead of dividing by this, let's multiply by the reciprocal. Let's leave this one alone. But instead of dividing by this, let's multiply by the reciprocal. Let's put it in the denominator. Does sine squared of theta divided by sine squared of theta go in evenly? Goes in one time. So what do we have? We have negative 1 over cosine squared of theta. Never leave your answer in the denominator, right? We talked about never leaving a trig function in the denominator. Move it up. What is this the same thing as? Ooh. And one of you got that correct. But now that you see it, I'm hoping you know how to do it. So let's take a moment because there was a lot going on in this problem. North person, I got negative secant squared of theta from this. What did I do to get to that answer? North person, you're explaining that. South person, I want you to tell them after they're done, I want you to tell them what you did incorrectly because only one person got it right. Everybody made a mistake or got stuck. I want you to explain what you got stuck with and how what you learned in that problem. Discuss, please. The other neat thing that made me just think while I was listening to a bunch of different conversations, you can learn a lot from making mistakes in this section. You can learn a lot. Like that will teach you more. Oh, I can do that. Your brain starts thinking in new ways when you get to these types of problems, which really means that you are going to become a better critical thinker. That's a good thing. I know that that's scary for some of you, but enjoy it. It's awesome. Number 25. Let me start you with number 25. Before I start you with number 25, what do you think you're going to do? There are 4 hints for you. Which hint are you going to use? Look at your 4 choices. Which of the 4 hints are you going to use? Say it out loud. GCF. Good. What is the GCF? Sine of x. X is your angle. Angles are trapped inside trig functions. Don't ever try to pull out the angle. Pull out the trig function. Keep it intact. Don't ever try to pull out the angle. Keep that in mind. The angle's not going to do anything for you. I would pull out a sine of x as your GCF. And then you should figure out what goes in the parentheses and then simplify with your partner. Go over it. We'll take 2 minutes and see what your final answer is. Go. It has been 2 minutes for number 25. If you got an answer, say your answer out loud.
Sine of x times 1 plus cosine of x times 1 minus cosine of x.
Whoa. Those guys were on the same page. That's not what I got.
Okay, that's not what I got either.
I know, but I didn't hear anybody say anything else. So, besides those guys, what did you get? That's not what I got either. But you're closer, I think. Ooh. Did anybody get anything else? What'd you get?
Sine to the third times x.
Sine to the third of x is what I got. Did anybody else get sine to the third of x? Raise your hand. 3. Okay. Let's go through it. Here we go. What's in the parentheses? Let's see. This is what it should be. First and foremost, let me make sure that you understand Gcf factoring, because some people only put a negative cosine squared, okay? So let's just talk about why that's wrong. There's 1, 2 terms here. 1, 2 terms. There better be 2 terms inside your parenthesis. Sine of x times what gives you sine of x? Sine of x has to multiply a 1 to get to that sine of x, and sine of x times negative cosine squared of x gives you negative cosine squared of x times sine of x. This is the correct first step. Then I see a Pythagorean identity. Since the sine squared of theta plus the cosine squared of theta is equal to 1, sine squared of theta plus cosine squared of theta equals 1. If you have 1 minus cosine squared and you subtract the cosine squared, I know what that's equal to. I have now made it smaller. I took it from 2 terms down into 1 term. This is now sine squared of x. And sine squared of x means a sine of x times a sine of x. And guess what we're multiplying by? Sine of x. We have a sine of x times a sine of x times a sine of x. The easiest way to write that as our final answer is sine to the third of x, because we have 3 factors of sine that are multiplying each other. South person, it's your turn. South person, how did Mr. Paramo get sine to the third of x? North person, what mistakes did you make? After they're done explaining how to get it, I want you to explain your mistakes and what you learned from them to your partner. Discuss, please. The reason why I picked these specific problems is because I know that there are some things from Chapter 1, Section 2 that we haven't talked about since Chapter 1, which was literally in September. We are in February still, right? Yeah, it is February still, for a few more days. And there are things that we did with x's and 1's and y's and stuff like that. And now we're throwing in sine and cosine. And if you never went back and learned the mistakes you were making back then they're going to show up as mistakes here. So that's one of the reasons why I'm asking you the question to tell your partner, hey, I made this mistake and I learned. Because that's going to help you not make the same mistakes. And you are going to be that much stronger when you get to this harder stuff. And it's not that hard. This is quite satisfying stuff. Like number 29. I'm going to tell you what. I'm going to give you a little bit of time. This will help the person who's at home watching or doing this. I want you to try 29 and 30. We're going to see what you guys get on both. I'm going to give you about 4 to 5 minutes to try both. And then we're going to go over both together. Go for it. When you finish one, go for the next, and so on.
It's just a alpha.
The cosecant of alpha.
Alpha.
Cosecant of alpha. This is a lowercase, think Greek letter A. Or maybe it's, is that uppercase or lowercase? Chris, do you know?
I think it's uppercase.
I think that's an uppercase alpha. Not a great, kind of like a fish.
I'm gonna make it
I don't know what the sponsor of that is, but turn that alpha kind of, usually ours are a little more pointy on the left-hand side. Okie dokie. We're going to go over number 29. Number 29, I walked around and I saw a lot of wrong answers. Matter of fact, I don't even know if I saw any correct answers, I'll be honest with you. I looked at a lot of different people's answers, and there are several people making a simple mistake. So let's start with number 3. A says multiply or FOIL binomials. If I FOIL this binomial, don't forget that cosine of k plus sine of k squared means you have a cosine of k plus the sine of k multiplying by another factor of cosine of k plus sine of k. Now, I saw some people do this part correctly, which is good. There were several people who did expand and then FOIL, which is what you need to do. If you did not do that, you didn't look at my 4 hints. I gave you one of the hints saying FOIL binomials. You cannot just square the sine and square the cosine and think that's good enough. Not for an A, not for a B. Maybe for a C or a D. But we're not going for that. We were going for A's and B's. Let's go. Cosine of k times cosine of k is cosine squared of k. Cosine of k times sine of k, I'm just going to write it plus sine k cosine k. And same thing there. Plus sine k cosine k. Because you can write multiplication in either order. I can put the cosine first or the sine first. It doesn't matter. So even though this was cosine k times sine k, I can write sine k cosine k plus sine squared k. This one sine k cosine k plus another sine k cosine k adds together. How many do we have? Those are like terms. That is 2 sine k cosine k plus cosine squared k plus sine squared k. There may or may not have been people who got this far. Now we're at the point where we have something different than the people who just tried to square this and square that. If you got this far, I'm hoping you knew to combine these two things. That multiplication can be written in either order. That's why I can put the outside product together with the inside product. We can add those together. There's 2 of them. And now, since addition is commutative, we can mix around our addition and subtraction. We can actually put this next to this because I'm just going to reorder what I'm adding together. I'm going to put cosine squared of k plus the sine squared of k next to each other, and then I'm going to add the 2 sine of k cosine of k right there. And the reason for that is I know what the cosine squared of k plus the sine squared of k is. It simplifies. It goes from 2 things down into 1 thing. Which means my final answer should be in either order 1 plus 2 sine k cosine k, or 2 sine k cosine k plus 1, or if you wrote the cosine k first and the sine k second, that is totally fine as well. Did anybody get that as the answer? Raise your hand. 1. I didn't see your paper. Good. So like I said, I didn't see any correct answers when I walked around. But I'm hoping you know what mistakes you made by now. If you forgot to FOIL a binomial, you need to write that as a note to yourself in your notes. You need to highlight that. You need to annotate your notes and make sure you don't make the same mistake, because I promise you, you're going to see something like that again. Now, some of you may have done this. This is an alpha symbol. When I draw it, it looks like this, something like that, when I draw by myself. But I don't know which font this was. It decided to smooth that left side out a little bit. You cannot swap out this is not an identity because this is not squared. This is just cosecant of alpha plus 1. So don't think of this as Pythagorean identity number whatever, 3. I have to FOIL this out first. 2 of them. Minus cosecant of alpha plus the cosecant of alpha minus 1. I have to do that first because there's nothing, I can't put that together with that. There's not an identity. I can't swap that out because the identities have to be squared in order to use them. The outside product is negative cosecant of alpha. The inside product is a positive. Guess what? That actually cancels each other out. Cosecant squared of alpha minus 1 is an identity. Cosecant squared of alpha minus 1 turns into something. What does this turn into? How many of you got that answer right? Yay! Some victory there. Perfect. So remember, lots of little mistakes. You can add up. If you found this video helpful, hit like, subscribe, leave positive comments if you'd like. Or criticisms for that matter.